These are notes for section 5.3, solved by elimination. This would be the third video talking about solving linear systems by elimination. But now in this video, we need to discuss those special case answers. And again, a quick recap. When we have a linear system, what we have are two lines, two or more lines. And what we're looking for is the ordered pair, the point where these two lines cross. That answer will be represented as an ordered pair x comma y. Well, these special cases would be lines that don't necessarily have an ordered pair as their answer. And we have two different kinds of special cases: no solution, they don't cross at all, no solution. And then we have infinitely many solutions, and that is that the lines cross all the points. They share all of these points, infinitely many points, infinitely many solutions they have in common. We've already discussed this with substitution, with graphing as well, and now we need to see how this looks when we are talking about elimination. So again, a quick recap to eliminate. We need to line up the variables, and then we need to make one of the variables the same, either the x's or the y's, and then we can add or subtract to make that variable eliminate. So if we look at number one, maybe I can zoom in here for you. On number one, the x's are lined up and the y's are lined up. In order to get these negative 3's, if I'm going to eliminate the x's, and again, you have a choice, you could eliminate the x's or the y's. If I'm going to eliminate these x's, that's negative 3 in front of this x and negative 3 in front of this x. Well, I have to either add or subtract the equations to make those negative 3 go away. If I were to add negative 3 plus negative 3, that would give me negative 6. And I'm trying to eliminate the variable, meaning make it 0. Well, negative 6 isn't going to get me there. So if I were to subtract negative 3 and negative 3, that's what's going to make them go to 0. So again, I have negative 3 and negative 3 in front of the x's. If I were to subtract these two numbers, negative 3 minus a negative 3, two negatives make that a positive. Well, negative 3 plus 3 is 0. So I need to subtract these two equations. Negative 3 minus negative 3, again, this double negative makes that a positive. That's 0. Negative 3, or I'm sorry, a negative 4. So I have 4 minus 4. 4 minus 4, that's 0 as well. And 9 minus a negative 3. Again, this double negative is going to make that a positive. If I were to distribute that negative 3, that'd make that 12. Well, both of my variables have been eliminated, both the x's and the y's. So I don't have any variables left in the equation. So what I have is 0 equal 12. Well, that's not true. That's false. And from the substitution on a previous video, when we have a false statement, we say no solution, which means those two lines don't cross. They don't share a point in common. On number two, my variables are lined up, x's and x's, y's and y's. But one of my variables is not the same. The x's are not the same and the y's are not the same. So what I need to do is multiply one or both of the equations. Well, I can multiply this top equation by 2, and that would make my x's both a 2. Now, one of them being negative, one of them being positive. 2 times negative 2, again, I'm taking this 2 and I'm distributing it through the equation. So that'd be minus 4y, and 2 times 5 would give me positive 10. So again, I'm looking at my x variables here. It doesn't matter which variable you want to eliminate. Eliminate one, the x's or the y's, it doesn't matter. So in this case, I'm looking at these two numbers, and I have negative 2 and a positive 2. So what I'm doing in my head is I'm asking myself, do I need to add these two or subtract these two? Which one would go to 0? Well, negative 2 plus 2 is 0, which means in my equation, what I have to do is add these two equations together, because that's what makes x eliminate. So negative 2 plus 2 would be 0. 4 plus negative 4 would also be 0. It just so happens they both eliminated. And negative 10 plus 10 would also be 0. So 0 equals 0. Well, that is true. That is a true statement. So what I have is infinitely many solutions, which means that these lines, these equations, are the exact same. one of them has a negative ran through it plus multiplied by 2. But if we were to graph them, if you were to graph both of these lines, both of these equations, you would see that they line up exactly on top of each other, and they share an infinite number of solutions where they cross. These are the special cases. No solution and infinitely many solutions. So let me walk through 2 more, and hopefully that gives you some clarification. Again, for elimination, line up the variables, make one of the variables the same. Well, the x's are already the same. Now you might say, but the y's are not. Okay, that doesn't matter. I don't need both of them to be the same. I just need one. Again, I'm trying to eliminate one of the variables. So I look at my x's. I have a -1 and a -1. Those are the numbers in front of x. I'm asking myself, if I were to add these two, -1 plus -1, does that give me 0? No, that gives me -2. If I were to subtract, -1 minus -1, a double negative makes that a positive, and that gives me 0, which means I am subtracting these two equations. So I take this negative, and you can think of it as you are distributing a negative, if that helps, to change all of the signs. So this is a negative here, this now turns negative here, and that's negative here. A double negative makes that a positive. So -1 plus x would be 0. 1 minus 2, or 1 plus a -2 is -y. And -1 minus 2, or -1 plus a -2 would give me -3. And I divide by -1, which gives me y equal 3. And you might say, which special case is this? Well, it's neither of them. It's not a special case. This is a linear system that has an ordered pair where these two lines cross. And in order to find out the ordered pair where they cross, I have to go solve for the other half of my ordered pair. I have a y value of 3, which means I need to take that 3 and substitute it back into one of the equations. Doesn't matter which one. So I'm going to look at the top equation, -x plus 3, that's plus y, equal -1. To get rid of a plus 3, or the inverse of plus 3 is minus, and to get rid of a times -1, I can divide by -1, which gives me x equal +4. The ordered pair where these two lines cross, that's a 4 there, is 4, 3. One more. Number 4, the x's are lined up, the y's are lined up, and the x's happen to be the same. Again, I'm looking at these x's, and I have a 4 and a 4. If I were to add 4 and 4, that would clearly give me 8. So I'm not adding, I'm subtracting these equations. You either have to add or subtract them. 4 minus 4 would be 0. -2 minus -2, two negatives would make that a positive, would also be 0. And 6 minus 3 would give me 3. 0 equal 3. My variables have both been eliminated. That's a false statement, so I would say no solution, meaning those lines don't cross. Hopefully that was helpful. I'll see you on the next one.